Okay, so now we're going to move on to the next part of missing data. So now we're going to think about methods to address the missingness. So again, missing data decisions are always made for each analysis you want to run, not for your data set as a whole, but for the analysis you're interested in. So if you want to compare the means of two groups on variable A, but variable A is missing for 20% of the cases, how will you handle that? So that's one analysis. If you want to predict variable A from variable B while controlling for variable C, maybe you have data missing on variables B and C, you still have to think about how to handle that. So in each of these cases, you might make a different decision because you have different variables involved. There's two basic options we're going to review here. Option A is delete things, and option B is multiple imputation. So the first one you've probably heard of, which is listwise deletion. Listwise deletion just means delete any case that's not complete. So anything that doesn't have data, we just delete them right out of there. So if we were looking at question 2 above, if you wanted to predict variable A from variable B while controlling for variable C, then you would delete any case that had missing data on variable B or C. That could be 10%, 12%, or some bigger number because somebody might be missing B but not C, or C but not B. So listwise deletion means that your sample size becomes smaller, first of all. Second of all, if these data are not missing completely at random and you have deleted them listwise, then you have changed the sample, how your sample can generalize. You'll change who your sample can generalize to, just like we talked about earlier. Yes, Dwani.
So, like how you said that you would delete the cases in variables B and C. So why would we not like delete the variables in variable A?
You would also do that. I just didn't say that there was data missing in
Okay.
variable A. But yes, if there was data missing in variable A, then that would also stack up.
Okay.
You can pretty quickly go from not much missing data to a whole lot of missing data listwise if you're thinking about data that are missing on every variable you want to include. So really, listwise deletion is best if you have data that are missing completely at random. And it's really not recommended if you have any other type of missingness mechanism because of the generalizability issue. And remember, you almost certainly do not have data that are missing completely at random, which means I don't suggest this method. If you see someone who uses this method in a paper that you're reviewing, then what you can do is bring this up. Like you've used listwise deletion, that means now your generalizability is different than you expect. They'll need to include information about that within the actual within the discussion. So even though you can delete, I do not recommend it because you lose cases, which is bad for statistical power. You change the generalizability, which I already said, and then also you lose the representation of people who started your data collection and then dropped, which can be problematic because in a lot of the work that we do in education, the people who drop out over time specifically are people who are of lower socioeconomic status. And we want to allow the effort that these participants have gone through to be involved in your project at all to remain in the project. By deleting their data out of the data set, we are just sort of canceling all of the work that they've done. So that brings us to option B, which is the multiple imputation option, which is what I'm going to spend the most time explaining to you today. And you may be like, multiple imputation? No way. I'm just a graduate student. There's no way I can do that. It's too fancy. Nuh-uh, my friends. Not only can you do it, you're fixing to do it. Okay, so the idea of multiple imputation is basically that you're going to use all of the information you have to make several plausible imputed data sets and then combine the results across all of those data sets. You'll get multiple data sets, hence the word multiple. You're going to impute, plug in values that are plausible for everything that's missing, and then run the analysis that you were interested in running multiple times, one for each of the data sets you've imputed, and then average across them all. When your data are missing completely at random or missing at random, this works really well. You can still do it if your data are missing not at random, but once again, we're subject to that generalizability issue.
I have a question about option A.
Sure.
So, say if you're running multiple analyses, do you delete the whole cases for each situation that you're running? Because, say, if you have different variable interests for these different analyses, like, say, if you're interested in predicting how much money a person has versus predicting how many dogs they have, and you're looking at different variables, would you delete all the cases for all the variables looking at them together, or would you delete the cases separately depending on the analyses?
So two things. First is I don't recommend you do this at all. So no. But if you were doing it the way that it would be separate. So you would run one model for each question that you have, and then the deletion would happen within each of those models. I still don't recommend that you do it because of all of those other issues that arise
Uh-huh.
when you delete data.
Okay.
But if you don't have dogs in the first analysis, just in the second, there's no reason to delete cases for the first analysis that have to do with dogs. Okay, got it. So for B, I said this, we're going to be either way, it's going to work well. So remember, we're going to have a missing data strategy for whatever analysis you plan to do. So you would repeat the steps that I'm about to explain to you every time that you have a new analysis that you want to run, because the missing data imputation is for an analysis specifically. So what I'm going to do now is I'm going to keep this number of publications and I'm going to predict it from mean support. Now, this is not whether number of publications is missing. This is I want to know if the number of publications people have is predicted by mean support. Now, what's really cool is that SPSS actually has an excellent multiple imputation module. It will do multiple imputation for you. It will account for your auxiliary variables if you just tell it which the auxiliary variables you should use. It will conduct one analysis per imputation, and it will average across the results. And it has a really easy to use graphical user interface, or GUI. And I have, this is the handout that I gave you, or you can follow through and download it right from the PowerPoint here. So you can follow along with me on that form. So let me pull that up. So this is what we've already done, which is identifying the missingness. And okay, so we've identified the missingness. We're going to check whether the missingness is related to things in our data. We checked it with one thing already. And then, oh, you can do it either way. I actually did it here with my dependent variable as the variable that I will use as my predictor later. It doesn't matter because we're looking at a non-causal directional relationship. We're just interested in whether they're related. So, step 4, this is our multiple imputation. And what I have done here is this is my explanation of what each line of this code does. And here I have put in the cars dataset information. Here is some base code. Well, this is incorrect base code, so I'll put in correct base code, which has no variable names in it. So the base code here would be variable 1, variable 2, variable 3, variable 4. I'm doing, this says do 10 imputations, and I'm going to make a new file name. Come here. So all this does is make a new, come on, why are you hiding? Makes a new data set that includes the variables that I have identified, both that are going to be in my analysis and that are related to the missingness. So let's move back to SPSS. Come here. So I'm going to move back to SPSS, and we've already checked whether this first thing was related to the missingness. Let's check something else. What was the other one we said that I thought? Oh, it was the type of degree. Type of degree? Program field. I think it might be broad field ID, broad field name. Let's look at broad field name. Oh yeah. 2, 3, 4, 5. 1, 2, 3, 4, 5. We've got 5 different categories here for broad field name. Guess what we know how to do? Will the logistic regression do this? Keep it separate? I don't actually remember. Let's try it in a GLM. We're going to and whether they're missing is going to be our dependent variable. We're going to look at we want to get our parameter estimates. Oh, I hit the wrong button. Oh well. All right, so we have 1, 2, 3, 4, 5 different categories of broad field of study. Looking through here, oh, we've got some. Looks like a couple of these are different than field 7 in terms of whether the data are missing. So that's telling me some information that this might be a useful category. Looks like 7 is different than 6 and different than 4, but not different than 2 and 5. I feel like we created a variable that was a little bit more condensed than that. Did I create it and put it down here? No. Okay, so then what we're going to do is let's create some new variables about this. Broad field name. Yeah. Okay, so our broad field names, what I'm thinking of in my head right now, sorry I wasn't saying it out loud, is how to code this so that we can sort of capture what's going on in a way that we can put it in our logistic regression or into our predictive model. Because right now we have this 1, 2, 3, 4, 5 category situation. 5 categories, if I just put them in, it's going to treat 7 as being 1 more than 6, 6 as 1 more than 5, and we don't have a way to distinguish that within the multiple imputation phase. So what we're going to do is create one that is let's take biological and health sciences. Go away. Okay, I'm saying that this person does not have a biological and health sciences degree. Looks like none of these. Oh, is this missing? Yeah, we've got some missing here as well. That's handy. So I'm going to make a new variable, and let's just, to make it really easy, let's use social behavioral sciences and not social behavioral sciences. So we're going to say if broad field ID equals social behavioral sciences, I guess I could figure out which category that was. 7, right? If broad field ID is less than 7, then SBS equals 0. Because in this case, we have 7, 6, 5, 4, 2 as examples. And then I'm going to also keep this. If it's missing broad field ID, then SBS equals blank. Actually, I'm not sure how to do that. Missing SBS? I may have to give this problem to Susan to figure out. We'll see if this works. Da, 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 da. Okay, so what I've done here is if broad field ID equals 7, then I've got SBS is equal to 1. Is that right? 631? No, what is it? 7. This is why you always check. 631. That's humanities. Dun dun dun. Okay, let's change it to humanities. Okay, if my broad field ID is equal to 7, then I'm talking about the humanities. And if it's not 7, then I'm not talking about the humanities. And if it's missing, then I want to make it set to missing. That's what I'm saying here. So I'm going to run this and we'll see if it works. It does not like that. Oh. It's because we don't use then in this code. Okay, it liked almost all of these. They didn't like this last one. So what I'm going to do instead is say I'm going to take humanities. And I'm going to say why can't I figure out how to do that? Okay, well, I'm not going to be able to figure that out right this second. Oh, yes I can. Yes I can, yes I can, yes I can. Oh, guys. The thing is, I can't see your faces that you're rolling your eyes at me, so I appreciate it. We're going to do the recode into new variables. And I can do that by hand. Nope. We're going to recode. The variable is broad field ID. And if it says 7, we're going to make it equal to 1, equal to 0. And then missing is equal to missing. And we're going to put it into a variable called humanities. Nailed it. 4th time's the charm. Okay, it looks like we have our variable. The missing did not work. Try that. Maybe I didn't have any missing. $631. Well, let's stick with this one because I'm not entirely sure if this is counted as missing or how it's counting this as missing. So, um,
Dr. Logan,
yeah,
at the end, like in SPSS, there's a line which says 19 record, the equal sign on the record command was not
yeah,
preceded. So I don't know if that is for this or what, but yeah.
yeah. It is. It's for this. It's because this isn't how you say that it's missing. So I
Okay.
think. Let me check one more thing. Okay. Transform. So from here. Ugh. Go over here. System or user missing. I want it to be system missing. Ah, SYSMIS. I just spelled it wrong. SYSMIS. Okay, hopefully that'll work. Let's see. Ah, come on. Last one. And then we're going forward. I did it. Okay, my problem is that I was using else here when that was saying if it's not 7, then I want it to be coded this, which is a problem because that was capturing all of the missingness in the other one. So now, I've got that representing humanities or not. I've got my frequencies of humanities are matching up to what I expect that they should be. 631 people do have humanities or are in the humanities and the rest of them are not. Okay, so now let's check and see if this is related to humanities or not. We're looking at logistic regression predicting whether they're missing publications from whether they are in the humanities. Remember, I'm going to skip right past block 0 because that's not telling us anything. Block 0 is not very interesting. Now we're in block 1. It looks like once again have not a significant relationship here between whether you're in the humanities or not. So we did not a good job of predicting a good variable here. What we can do, ideally what we should do in this case is then to go through and we'd make lots of categories for different variables. I'm not going to do that right now. What I am going to do is I'm going to show you how this works, pretending like humanities is a significant predictor. So we're going to keep has kids and humanities because we're just going to try it to show you how it works. So now let me show you how this multiple imputation works. All I'm doing here is I'm saying multiple imputation and the, what's the analysis I said I was going to do? Analysis? The analysis I want to do eventually is a GLM where I'm predicting number of publications from the number of publications from what did I say? Not satisfaction. Satisfaction? Yeah. No, support. From overall support. So variables that I know I'm going to use are going to be this outcome variable this mean support variable, and then anything else that I think is related to the missingness or that I have found is related to the missingness, in which case it would be humanities and has kids. Even though we have found that those are not related, I'm putting them here to sort of demonstrate how you would carry it through. Let me get this GLM code. Ah, what did I just do? Analysis I want to do eventually is A11 underscore A underscore 2 by mean support. So that is what I want to do eventually. But first, here, let's look and see how much, oh, not by, with mean support. Okay, so when I've done that, let's look and see what our degrees of freedom are, because that's going to talk about our total sample size. Looks like we've got 4,238. So we're dropping some cases here as we're predicting this model. So now let's do the multiple imputation. The multiple imputation follows this code right here. I put in my variables that are going to be involved in my analysis I care about, and the things that I have found predict either of the missingness on either of these two variables. I'm telling it to make 10 imputations, and I'm going to tell it to put into a new file called grad pubs imputed. Oh, good. Alrighty. Well, maybe we'll do it through the GUI. Because for some reason my code's not working today. Sorry guys, I did this once before we talked, I swear. Impute missing data. So what we're going to do is put some variables into this model. I'm going to kick this up to 10. I'm going to just throw some stuff in here and then paste it so I can check my code. I'm going to write a new data set named grad pubs imputed. And then I'm going to paste it. Oh my goodness gracious. Look at all of that fanciness I didn't do. Okay, so all I just did then was take the variables that I've saved, and I've pasted them here. And then, yeah, that's it. Let's run that. Okay, you see it down here, it says it's running multiple imputation. It's going to take a minute because these data sets are big. Okay, so while that's happening and running, I feel like I just rambled like absolutely crazy. So who would like to make me go back and explain some of the things I just did? Yeah, go ahead, Sarah.
Can you give us a summary of how you went from step to step? I kind of got lost as you went through that.
Sure. So part of that is because I didn't have my code written in advance. I thought that would be a fun adventure for us. Shows you what I know. Okay, so from step to step, the first thing you do here is you're going to create this variable about missingness. Then you're going to predict that missingness from the variables in your data set that you think might be related to it. Here I had to make a new variable to predict because we didn't have one that represented what we wanted. So that's what I did here. And then I'm predicting my outcome. In this case, it was missing publications. And then here what I've done is just demonstrate the analysis I'm going to want to do eventually, but I'm not going to do it yet because I haven't imputed my data, but it's right here. So then here's my multiple imputation syntax, where I'm telling it, here are the two variables that are involved in my analysis I'm interested in, and here are two variables that theoretically would be associated with missingness on one of these two variables. So these are the four variables that I'm going to include in my multiple imputation. So by including these two variables, theoretically what I've done is improved the prediction of the missingness and done a better job at imputing plausible values for people. So what has happened? Does that sort of streamline the process a little bit better, Sarah, for you?
But I'm still kind of confused about the part where you say you predicted missingness and then you predicted outcome.
Mm-hmm. So when we're predicting the missingness, so here I created this variable called is it missing? And then here I'm predicting whether it's missing. Remember on that publications variable, let's take a look at it. A11 A_2. So let's take a look. Oh my God. What is wrong with people? 290. So if you look at this variable, apparently it's sorted in order. 2, 1, 0, and then look at this. Everybody else is missing. So starting right here, everybody else has missing data. So if you look at the variable I created called miss pubs, you'll see that it switches from 0 to 1 here because here it's missing. So what we're doing,
So
oh, go ahead.
I think I get it. You're using this to later compare to the other two variables you were interested in. Is that correct?
Yes,
Okay.
because what we want to know is this related? Here, let's put these two in together, as Duani suggested. And let's just throw in one more thing here. How about year first enrolled? How about year first enrolled in the doctoral program? So now I have three predictors in this model, predicting whether or not it's missing. And I'm going to scoot on down here. Here within this, oh, look at this, you guys. Within this big model, having kids is moderately significantly related to my whether or not it's missing. Being in the humanities is significantly related to being missing. And what year you were first enrolled in the doctoral program is also significantly related to the missingness. Cool. So now we have some idea of why people might be skipping the data, skipping filling this part out of the survey. So now I'm going to take those variables, all of which were related to my missingness, and I'm going to pipe them forward into my multiple imputation model. So now I have my outcome that I want to do eventually, my outcome, my predictor, which is the mean support variable, and then these three variables which were related to my missingness. And I'm actually going to run that again. Oh, I did the wrong data set. What? Why is it mad at me again? You guys. What's it called? Activate? Data set activate? Anybody remember? weird. Multiple imputation.
Is it data set declare?
Ooh, it might be declare. I think you might be right. I think you might be right. Still does not do it. Oh, you know what? It's printed right here. Let's back up. It was data set declared. I see. We have to tell it. Oh, yeah, okay. We have to tell it, hey, I'm about to create a new data set and it's going to be called grad pubs imputed. Get ready. Here's what I want you to put in it. Totally forgot about that step. I apologize. All right, so now it's running. Now it's running. All right, so following the steps, we're creating the missingness, we're checking for what's related to the missingness, and then we're doing this multiple imputation to get lots of data sets and check them. Ooh, look at this. Overall summary of missing values. Okay, let's take a look. Our multiple imputation is done. We've gotten 10 data sets. We have 5 variables. None of those variables have complete data. Cool. Of the cases, it looks like we've got about 82% complete data. It also then gives us information about all of the different values that they've imputed and the missingness from each one. Now, that's just interesting to look at. Now let's take a look at this new data set it created, and you'll see a couple of things. Here it is. It is called untitled, but it's called grad pubs imputed. And what you'll see is a new variable called imputation is here at the beginning of the data set. That tells, so 0 is the original data. And then look at, we've got so many data sets here. This is data set 1 from imputation 1. And then I can scroll on down and I'm on data set 6 of all of the 10 data sets I asked for. And then what you can do is, if you take a look at where some data are missing that we care about, like here, humanities. Like, look, it's still missing in humanities right here, but that's because we're in data set 0. I can switch into any of these data sets. So let's go to data set 2. And you'll see that it's highlighted where it has imputed new data for you. So now I'm in data set 2. I can go to data set 6, and there's the cases that it's imputed. It's only imputed variables, only imputed cases where I have asked it to do this for the particular variable. Okay, so I've gotten 10 different data sets. There's another one that's been imputed over here, has kids. We should also have some for, yep, mean support. They've imputed a mean support variable there. Now it's different for each time it's been imputed. They're not always the same. So what we can do next is, check this out. Your normal things that you're used to, do you see this little swirly guy on here? That's because now it will do the pooled multiple imputation analysis for you. So we can, A11, I'm not going to remember it. We're just going to have to do it like this. Model. So what I'm doing right now is I'm getting some code to use in the next, like so I can replace it with our actual variables. Give me the parameter estimates. Okay. So now I'm working from the imputed data. I'm activating the dataset gradpubs imputed, which in this case is just saying this is the one I want you to use. And what I'm doing is saying, remember, this is my model. I'm predicting number of publications from mean support. And I'm going to also include mean support here. So when I run this, it will not be happy. Guys, I don't know what the heck my deal is today. Oh, I see. I had the wrong variable in the command. Okay, so now check this out. Right here, you get, not only do you get the results from the original data, you also get it for every multiple imputation that you've run. So here, remember I told you we were going to look at the degrees of freedom? We've got a total sums of squared in our listwise deletion, which is what it does by default. So if you guys have never thought about missing data before, what it's done by default is this listwise deletion. So we have 4,238. Here, now we're up to 5,040. 5,040, 5,040 for all the rest. Okay, so I'm going to scroll down, 8, 9, 10. It gives you an R squared for each one. And then we also get parameter estimates for each one. And we get parameter estimates for the pooled sample. So we're going to get parameter estimates not just for each of those ones we've imputed, but also for across all of them. So this is what you would report within your analysis. You would say, are these related? Let's look. My mean support is not significantly related. Significance. It's not statistically significantly related to the number of publications.
Dr. Logan,
Mm-hmm.
if we are missing for all of the variables we're interested in, is that the percentage that's still missing? Is there still a percentage missing when it's imputed? So if we don't have an answer on any of the ones that, so if it's, poorly worded question. if the case is missing across the board, on all of the variables we are interested in, can it still be imputed or is it still missing?
It would still be missing. So if you have 5 variables involved in your analysis, or 2 variables involved in your analysis and 3 auxiliary variables, whatever, if all of those data are missing for a particular case, that case can't be included because you have no information to make a guess about them. Now, if they're missing on only one of them, you're fine. I actually even think if they're missing on both the outcome and the predictor, but you have auxiliary information on them, you can still do some imputation.
Got it. And is that what's listed in the fraction missing info here on the parameter estimates table?
Yes. How much data is missing on this variable? I got one more. Was that Adriana?
Yeah, well, I think. Well, actually, I have 2 questions. So is this a procedure that you would do even if you don't find any variables related to missingness? So you can't create any auxiliary variables, you just wouldn't include them?
Yes, so you can, there's 2 schools of thought on that. So if you have nothing is related to your missingness, then you can do a couple of things. The first is you can include a couple of things that theoretically should be related to your missingness and include them anyway, even if they don't statistically predict. You can do that. The second thing you can do is just run it without any auxiliary variables. And again, that word auxiliary variables just means these 3 variables, which notice they don't end up in the analysis, but we used them to create the imputed information.
Okay, yes, that's helpful. And then my other follow-up question is like, what are you supposed to consider or keep in mind when you're trying to determine like the number of imputations to run? Is like 10 the standard? Is there a range? Is it like theory based? Like,
That's a great question. And what an excellent transition. So what we're looking at next, how many data sets to impute. And there's actually quite a bit of schools of thought on that. And in the missing data guidelines document, the decision tree, we call it, we walk through several. And there's no ultimate conclusion, unfortunately. So all you need to do is argue for it. Actually, usually in my own practice, I just use 10. And that's just what I do. And that seems to work pretty well most of the time. If you want to have a better decision tree, a better argument besides I just wanted to use 10, then Graham suggests that the more missingness you have, the more imputations you should do. And then White came up with this guideline, which is looking at the highest percentage of incomplete cases. So if you have one variable where 30% of your data is missing, then you would have a number of imputations. That's what this M stands for. Number of imputed data sets would be 30. So that's a nice guideline you can go by. So if you have something like one of your variables has 5% of your data missing, 5% of the data missing on those cases, then you would do 5 data sets.
thank you.
I love when I get to answer a question for real instead of just having to look it up, which I'm always happy to do also. Okay, I just walked you through all of the missingness. I will give you all of that code because your homework assignment this week is to do this either with your data that you're using for your final project or with the data set that we were using today, which I'll point you to on the homework assignment. I'll have that posted for you tonight because I want you to get a chance to get this under your fingers where you can send me questions and talk to Susan about how the heck it's working. It will have specific guidelines. I'm not turning you loose and saying impute data. I'm going to give you specific walkthroughs using my guidelines that I have within this PowerPoint. Things like step 1 was this, so answer me about this part of the question. And that's it. This is the last assignment of the year, which is bananas, other than the final project, which you'll return back in on the last day. And then don't forget to fill out that the survey for me online so I know what to talk about next week.